Dynamic pairing is a feature in the Q-SYS Designer software that allows you to logically pair the virtual representation of a hardware component in your design with the matching physical hardware device when it's connected to your network, without having to reload your design. If you weren't using dynamic pairing, then the only way to add new hardware is to take your system offline, update your design, and then redeploy, something that you don't really want to do if your sound system is crucial in running your business. Dynamic pairing lets you plan ahead for expected additions and changes, or unexpected changes, by telling the system what to do when those peripherals are found on the network. Let's say you're designing a system for a large hotel center with multiple conference halls. There's a bingo game scheduled every week, but it changes halls weekly depending on scheduling availability. The bingo operator has a multimedia cart with a microphone, and a laptop, and a projector, and a drum machine, because this isn't normal bingo, this is awesome bingo. All his inputs are wired to a single QIO device on his awesome bingo cart, which can move from room to room. But rather than burden that cart down with loudspeakers and an amplifier too, we want to use the installed loudspeakers already in the hall. All he should have to do is plug his QIO device into the network wall plate in whichever hall he's in, and his audio will automatically play from that room's loudspeakers, but not the others. So how is that possible? Let's take a look at a very primitive version of this design. Here we have 4 different audio paths, one for each of the 4 halls. We're then going to add 4 separate QIO devices and integrate one into each of the hall's signal flows, even though there will only ever be one physical device in reality. So in each of these rooms, the QIO audio brings each of the audio sources together with a simple matrix mixer. I've added an automatic gain control to keep the bingo operator's levels in check, and then that gets mixed together with all the other primary audio content for this hall, whatever that may be, before it's sent to that room's amplifiers and loudspeakers. Again, we've added the audio path into each room with a separate QIO device, even though we know that at any given time, at least 3 of these won't even exist on the network. But we'll configure them for dynamic pairing, so each one is always ready to become active when the roving device is connected appropriately. First, I'll click on the QIO in Hall 1 and go to its Properties panel, where you'll see the Dynamically Paired field. Let's change this to Yes. And quite importantly, let's also change the Is Required field to No. If a device is considered required, then it will register a fault if the device is missing from the network. So if we fail to turn off the Is Required fields, our core would constantly be filled with faults from these missing devices. Once we've made those changes to all 4 devices, we'll push this design to the core, and you'll notice that any device that is not required simply shows a gray bar around it stating that it is not present, without registering a fault with the core manager. Obviously, if you don't have a core and some extra peripherals handy, you won't be able to replicate this part on your own, so just watch me here. We're going to connect the QIO to the wall plate in Hall 1, which happens to be wired to port 5 of our network switch. Meanwhile, let's access the core manager, either by entering the core's IP address or by selecting its name here on a running design. You'll see a new tab that's titled Dynamic Pairing. This tab only exists when you've configured the properties of at least one device to be dynamically paired. Here, you'll see a list of all the devices with that property engaged, which are my 4 theoretical QIO devices. Select Edit, and then choose a method for each device, either network name or switch port. The scenario we're working on requires the switch port method, which means that we primarily care about where the new device is being plugged in. In the pairing field, we can see the port information of where it found that device. In our case, this comes in the form of the port's MAC address, but different switches may provide different labels. We're defining Hall 1 right now, so let's select that port for our device that's integrated into Hall 1. Once this is done, the system will always look for this model of QIO ML4 device on that specific port, regardless of what name has been provided to the physical device. A nice benefit of this is that I'm not just limited to the bingo cart plugging in here. I may also have a DJ with a QIO ML4 device in their gear, or a dance instructor with a QIO ML4, etc. Any of them could all plug into that same wall plate whenever they want, and the system will treat them the same. Another very common use for this switch port mode of dynamic pairing is to allow for hot swapping of devices in your system. Let's say an unprotected touchscreen controller in a school gymnasium has an unfortunate meeting with a flying baseball bat. Normally, to replace that, you'd have to either get a new touchscreen controller and rename it to match the old one, or even worse, take the system offline and change the name in your system to match the new device. But with dynamic pairing, you can just remove the old device and slap in a new one. As long as it's the same model, you'll be ready to go in seconds. The other method of dynamic pairing is network name, which essentially allows you to link a device in your design to a physical device on the network without renaming that physical device. While the system is running, you could dynamically relink your inventory item to any device of the same model that's discovered on the network, which could be useful for testing the system or replacing devices in a pinch. All right, back to our hotel halls. Let's disconnect that bingo cart from hall 1, wheel it out and bring it over to hall 2 and connect it to the wall plate over there. We'll repeat the dynamic pairing process in the core manager. Now, keep in mind that the device has to reboot, and with some switches, it may take up to a minute for the core manager to populate the new port information. So we're gonna fast forward this process so you don't have to just wait with me. We'll repeat this process with each hall, pairing the correct virtual device with the MAC address of the switch port in that room. It's worth mentioning that in order to use this switch port method, your switch must support the Link Layer Discovery Protocol, or LLDP. LLDP is a vendor-neutral link layer protocol used by network devices for advertising their identity, capabilities, and neighbors on a local area network. And if you don't know what that means, then just ask your IT guy. And make sure LLDP is enabled on your switches. Then buy the IT guy some lunch too. You know, he works really hard. Once all those pairings are complete, be sure to hit Save in Core Manager. Now that my system knows what to look for, let's see it in action. I'll play some music on my bingo cart and plug it into hall 1. You can see that it automatically pairs the QIO device with this first one in my design, and it plays through hall 1's loudspeakers. You'll notice that it's not playing through any of the loudspeakers in the other halls. I can disconnect it from hall 1 and go connect it in a different hall, and once again, it will be paired to a different device in your inventory, and it will become active over there. You don't need to shut down the system to add the peripheral. You don't need to do anything else in Core Manager. It's literally as simple as plugging it in, and it works. Thanks for watching.